Hello students, welcome to Spectra Education Academy. In this video, I am going to explain answers for VSAQs in the chapters Semiconductor Devices and Communication Systems. First question, draw the circuit symbols for PNP and NPN transistors. Okay, so for any transistors, there will be three regions. First, let us complete PNP. There are three regions for any transistor. So you can call it as this is emitter. This is going to be base and collector. In case of PNP transistor, IE, so current due to electron, because PNP, emitter is P, base is N-type semiconductor and collector is P-type. So current is mainly due to holes, so positive charges. So current is in case of because of the flow of positive charges, the direction of current as well as flow of charges, particularly holes, the same. If current is due to positive charges, the direction of current as well as the positive charges is same. And that too here, current due to the charges get converted into current due to current, emitter current is split into base current as well as collector current. This is in case of, don't forget to write the symbol properly. This is PNP transistor circuit symbol. Now coming to NPN. Here, this is again collector, this is again base, this is again emitter. And so this is NPN. So here, both base current and collector current are joined and it will be as emitter current. But the overall equation remains same. IB and IC turned as IE. So this is the answer for the first question. Moving to the next question. Which gates are called universal gates? The answer is, for second one, both NAND gates, and NOR gate are universal gates. The reason to say, you can make use NOR gate and a NAND gate to get a NOT gate. So you require one NOR gate to get NOT gate. To get OR gate, you require two NOR gates. To get AND gate, you require three NOR gates. So making use of three NOR gates, you can construct AND gate. Making use of two OR gates, you can construct. Making use of two NOR gates, you can construct OR gate. Making use of one NOR gate, you can construct NOT gate. Similarly, to get a NOT gate from NAND, you require one NAND gate. To get a OR gate, you require three NAND gates. To get AND gate from NAND, so you require two NAND gates. So this is the answer for this question. Next. Question number 3. In which bias can a GNR diode be used as voltage regulator? So it is answer is a reverse bias. A heavily doped PN junction diode operated in reverse bias mode. bias mode is called voltage regulator. Yeah. Moving to the next question. Question number 4. What is PN junction diode? Define depletion layer. A P-type semiconductor, P-type semiconductor and N-type semiconductor. N-type semiconductor separated by a junction, and it has two terminals. Two terminals is called PN junction diode. PN junction diode. The other part of the question is define depletion layer. A region, depletion layer, a region without any charge carriers, formed at the junction due to recombination of both electrons and holes is called depletion layer. Moving to the next question. What is P-type semiconductor? What are the majority charge carriers and minority charge carriers in P-type semiconductors? Question number 5. If a trivalent impurity like boron or aluminum is added to the pure semiconductor, the semiconductor so formed, in particular extrinsic semiconductor so formed is called P-type semiconductor. So what are majority charge carriers? Means holes are majority charge carriers. Holes are majority charge carriers and electrons are minority charge carriers. So just a converse of this particular definition. What is N-type semiconductor? So a pentavalent impurity. Like arsenic or antimony is added to the pure semiconductor, the extrinsic semiconductor so formed is called N-type semiconductor. So other part of the question is what are majority and minority charge carriers? So electrons are majority charge carriers. Majority charge carriers. And holes are minority charge carriers. So moving to the VSAQs in the next chapter, that is communication system. So first question is define modulation. Why is it necessary? The answer is the process of combining low frequency audio signal with high frequency audio signal. High frequency audio signal is called modulation. It is necessary because to reduce the size of the antenna. Second is to increase the effective power. Effective power radiated by antenna. And third, to avoid mix-up of the signals with different transmission signal. Next, moving to the next question. Question number 2. Again, part of the question is repeated. What is modulation? Mention the basic methods of modulation. So again, the process of combining low frequency audio signal with high frequency audio signal is called modulation. The basic methods of modulation is frequency modulation. So that is FM. Second is amplitude modulation, AM. So frequency get modulated, amplitude get modulated. This is AM. And phase modulation. So that is PM. Moving to the next question. What are basic blocks of communication? So first one is a transmitter. Second is transmission channel. And third one is the receiver. Moving to the next question. Question number 4. Mention the various parts of ionosphere. So the first part is part of stratosphere. So the range is 67.5 kilometers above the earth. Above the earth. Next, second is again part of stratosphere. Part of stratosphere. This is up to 100 kilometers range above the earth. Next, third, part of mesosphere. So its range is 170.19 kilometers above the earth. And last, thermosphere. So 300 kilometers range during night time. So 250 to 400 kilometers during daytime. Right. Moving to the next question. Mention the basic methods of modulation. So first method, as already we discussed, frequency modulation. That is FM. Second is amplitude modulation. Amplitude modulation, that is AM. And third is phase modulation. So that is PM. Moving to the answer for last question. What is a skywave propagation? Yeah. So answer is question number 6. Long distance. Short wave communication. Long distance short wave communication is possible due to ionosphere reflection is called skywave propagation. Thank you, students, for watching my video, but don't forget to share and subscribe with your friends and relatives. So in my next video, I'll explain the solution for numericals. So those numericals may be coming in VSAQs or SAQs or LAQs. So all numericals will be covered. Thank you very much once again.